All right, we're right at 5 after the hour. So let's talk a little bit about what's new in Event Endpoint Management. We got a couple of our guys from the lab, Matthew and Chris, joining us today. I believe Matthew is going to kind of lay out things for us, and Chris is going to do a demo. But don't forget, we've got the chat going. We're monitoring that, and any questions you have, just place them in chat, and we'll get you an answer. And so without any further ado, Matthew, you want to take it away?
Absolutely. Thank you very much, Ray. So good morning, good afternoon, good evening, everyone. My name is Matthew Churgwin. I'm joined today with my colleague, Chris Patmore. We're both engineers working on Event Endpoint Management, and we're here today to share what's new in the world of Event Endpoint Management. As Ray just mentioned, please do feel free to ask questions in the chat. We'll be monitoring those, and we'll have some time to answer some questions, hopefully at the end as well. So what's new in Event Endpoint Management? Well, as I'm sure most of the folks on this track here today are well aware, the proliferation of events and the event-driven enterprise is accelerating across lines of business and industries and sectors. Becoming a real-time event-driven business is a differentiator, and those who are adopting and embracing events have seen that return on investment and that value that events bring. It's allowing them to build new and interesting applications which allow them to provide better, more personalized experiences for their end users and rewarding and building that rapport with them. It's allowing them to gain insight into just how they are currently operating, spotting opportunities for efficiency improvements, and opportunities to perhaps gain new insights and leverage those in new applications as well. Being event-driven, it also enables you to, for example, mitigate and manage risk and drive automations without need of a human in the loop, and dealing with potential outages and issues, for example, without them becoming an issue and impacting your business. So while events and event-driven are being adopted with great fervor, as with every technology, every new solution, new challenges will arise when you become event-driven. For those who are advocating this new style of integration, how do I, as an event evangelist, accelerate adoption, show the value to my business, advocate for best practice? How do I educate folks on how to best use events? In the grand scheme of things, events are still relatively immature, skills are building, but there's a degree of best practice and education which still needs to occur. As, say, an application developer, I've realized the value of events. How do I know what streams, what events actually exist in my organization? Where can I find that list of what I could potentially leverage and use? How can I tell which streams are actually current and truthful? Which streams I'm allowed to use, which perhaps contain sensitive information and need to be handled delicately? And perhaps as a provider of events, how do I track who's using my topics, who's using my events, manage them, make sure that they're being used appropriately with the proper security and control? So that is where Event Endpoint Management comes in. We're a capability, part of the event automation offering, and for those who are not aware, what Event Endpoint Management offers is the ability to offer events in an API-like manner, addressing all of those kind of challenges and concerns that I was just alluding to. With Event Endpoint Management, we allow domain experts to quickly discover their event estate, be able to describe and provide high-quality API-like documentation describing key aspects that a developer, for example, would need to know: schema format, the schema itself, meta information like how frequent and, for example, how many replicas or partitions in a Kafka world, for example, you may need to worry about. We provide a catalog which allows the easy socialization and reuse of events. You would have a one-stop shop for anyone in your organization to discover your events, sign up and make use of them as well. And we provide a suite of governance, policies, security and other tools to help you manage and understand usage, make sure that bad actors do not misuse events, and that you'll be able to maintain complete control at any time. So given that Kafka is in particular a widely adopted event-driven technology, we've focused our implementation so far on Kafka, and there's just a bit of a refresher and a recap. Event Endpoint Management is comprised of two components. So we have our Event Manager and Event Gateway. The Event Manager is the location where a technical expert, a domain expert, can very quickly discover their Kafka topics, for example, and we assist in the discovery, the documentation, to result in an API-like definition which can then be consumed by others. We allow you to define rules of engagement. We refer to them as controls, but think of them as policies, not only to protect the events themselves, but how an individual can sign up to make use of those events, but also to protect your actual Kafka infrastructure as well. All of this information comes together and is published together into a centralized catalog, and you're able to maintain and perform day two style processes from the event manager as well. You can see who is making use of your events, manage them, get in contact with those folks in case, for example, there's an evolution of the event coming, so on and so forth. The event manager also acts as our catalog, our discovery. It's the index for an organization where you can go as an application developer, for example, discover events, understand how to use them, what rules may be involved, so on and so forth. Our catalog is searchable and indexed. You'll be able to search for key terms, tags, and very quickly and easily find any events that may have been shared in your organization. Not only that, we help our domain experts by providing a range of other tools to help a user get up to speed. We provide code, configuration, as well as other exports such as async API, all to help accelerate and gain understanding of how to interact with this particular stream of events. We allow users to onboard, request access in a self-service manner, and we also have an integration with our sister product, IBM API Connect, where this same catalog of events can be integrated into API Connect, and you'd be able to potentially share the same backing service in two different styles of integration pattern: asynchronous in the case of Event Endpoint Management and Kafka topics, and synchronous in, say, REST APIs. So you can bring those together there and offer in the API Connect developer portal a kind of a complete view of both synchronous and asynchronous styles to integrate services together. So all of this is kind of brought together and exposed and enforced by our Event Gateway component. Now, the Event Gateway, it performs two core kind of capabilities and purposes. It provides not only a point of abstraction, but it is the enforcement point for any policies, rules, and governance that you may have put in place. So by acting as a point of abstraction, that means that your, for example, Kafka producers or consumers do not need to actually directly connect to the Kafka cluster in question. You can abstract that away, use this gateway to, for example, perform some additional infrastructure management, checking and balancing to make sure that, for example, a badly behaved client can't get through to the real infrastructure and potentially impact other clients. Our event gateway is also scalable. You can have many of them. So if one were to fail, you'll have another event gateway available for those clients to connect and continue to operate and work. The gateway, as mentioned, also is this policy control enforcement point, and that's Kafka protocol transparent. It means that your applications as written today, do not need to be modified to work with the gateway. They will just connect, consume using standard Kafka configuration points. And our enforcement, being at the Kafka protocol level, allows us to do something that we refer to as Kafka virtualization. That allows us to create derived virtual views of topics as a client connects to them in the gateway. So as an example, if we have an orders topic and it has some, for example, sensitive information, say a credit card number, if exposed through Event Endpoint Management and leveraging our policy, our redaction policy or redaction control, the gateway can actually redact or hash out sensitive information as that traffic flows through the gateway. The nice benefit there is I haven't had to create a second Kafka topic with just that redaction on it, saving obviously some real estate and applications to do that processing. So not only can we virtualize, if you will, the Kafka topics and data, and you can publish the same topic many different times with many different policies applied, but it also allows you to abstract, as I say, many Kafka clusters behind one public entry point. Lastly, gateways, they are very lightweight and scalable, they're stateless, and they are managed in groups. So while you deploy individually, you operate and perform changes at a group level. So it's very easy to scale out and manage them from a day two point of view. So With all that being said and done, and a little recap of Event Endpoint Management, what's new? So the team has been working very hard, working with customers, hearing use cases, and we've added a range of capabilities to the product in the last 12 months or so. Today, we just wanted to highlight 4 of those, and my colleague Chris will be running through a demo to kind of show these in action and application. But just to introduce them to you, the 4 we'll be talking through today and showing is Mutual TLS, Internet-facing gateways, Open Telemetry, and lastly, quotas. So Mutual TLS is a new feature added relatively recently where we will allow an event endpoint management gateway to check and enforce that a connecting Kafka client, be it a producer or a consumer, is using a Mutual TLS or a certificate to help identify themselves. This integrates with any existing public key infrastructure that you may already have. And when configured in Event Endpoint Management, you just need to provide a few details. For example, the issuing certificate, the certificate authority, for instance, and perhaps a few details such as the common name to help identify individuals. You can, in addition to expecting a certificate to be presented, also make sure that the gateway checks for the presence of a username and password. And lastly, with our Mutual TLS capabilities, we've also allow Event Endpoint Management to connect to Kafka clusters, which are also managed and authenticated using Mutual TLS. The next feature we'll be talking about today is something we refer to as internet-facing gateways. This is a set of features and work we've done in our event gateway to allow it to be deployed in the DMZ. And what that enables is for a Kafka topic, perhaps only available internally, to be socialized with business partners or other folks over the public internet, for example. Not only that, it's composable. If you have existing TCP proxies, such as say Nginx or IBM Data Power, we can work with those. And what the Event Gateway provides is a set of additional security options and controls, such as tar pitting and lockouts, to make sure that if there is a bad actor trying to access your infrastructure, the gateway takes the load and makes sure that your actual Kafka events are not accessed. This is complemented with the addition of Open Telemetry support. That's been added to both our Event Manager and Event Gateway components, and this allows new insights to be derived about usage, not only of Event Endpoint Management, but particularly of Kafka clients. We emit a range of metrics, including number of connected clients, number of messages, error rates, system health, and these can be used with any compatible Open Telemetry collector to query and understand actually how your Kafka clients are actually behaving, spot bad practices, reach out to the individuals responsible for those applications, and make sure that they conform and behave a little more sensibly. Lastly, we'll mention our Quota Enforcement control. This is the new capability added to the Event Gateway, which effectively enforces a rate limiting through either number of messages sent in a time period or volume of data, or both. This stops clients, for example, spamming a Kafka cluster with lots of events very, very quickly. As we can kind of see here on the graph, we've got a client which, up until it was hitting its limit, was kind of growing quite quickly there. But once the quota control kicks in, it averages that load out over time, bringing that client back under its quota, meaning all clients will get a fair share. So with that little introduction, I'll now hand over to my colleague Chris to give a demo of all these kind of features in context. So over to you, Chris.
Thank you, Matt. Let me just take the screen. All right, hello. So yeah, I'm going to demonstrate the features that Matt just talked about, and I'm going to do this from the perspective of an invented company called Modo Genes, who are a company that sell jeans. And they're actually already a customer of EAM. They're already using the catalog and the gateway to consume events within their internal systems. They could be using events to improve the performance of their reactivity of their UI applications or something like that. But they're starting to think about how they want to take their usage of EAM to the next level. And in particular, they're thinking about how they might want to start publicizing some of their streams of events so that customers or third parties could consume those events directly to build new apps or to just have a better, more reactive understanding of how things are going with Modo Genes. In this particular example, we're going to be using a stream of stock payload events. These are just very simple events that tell us how much stock is available for a particular item in a particular store and when we might expect a new delivery of that item. And so Modogene's a bit worried about the security of this new world where they're starting to go public. So they're going to focus here is going to be on improving that security posture and protecting themselves from these public clients. I've already got an application running through the gateway that's consuming data and an option published that's enabling that consumption. But this option is published on their own internal gateway and isn't particularly secure. Anyone can get hold of it provided you can log into EAM, which isn't going to work when they make things public. So the first thing they're going to do is archive this option because they don't want anyone else subscribing to it from now on, and they want a new one which will be more protected, which we're going to call store stock internal. And they're going to add to this some controls. So the first thing they want is approval. You're not allowed to get access to this option unless you've been approved, so we're going to add that. And the other option we're going to add is the first of our new features, the TLS control. So at this point, the admin or the author has to come in and configure the control. The first thing they need to do is select the CA certificate, which will trust the certificates that are being used for client authentication. So I'll do that now. And then they have to provide at least the common name as a detail about the certificates they're attempting to connect. In this case, they know that all of their certificates have the common name of Modo clients, and they're actually also interested in making sure that all the certificates have the organization of Modo genes. At this point, the certificate, this rules can be tested using an example certificate, which shows that that certificate will match these rules. And actually, Kevin realizes at this point that sometimes the client common name is a little bit different, so he changes it to a wildcard and checks again. The next thing he has to choose is how clients will be identified when they're using MTLS. Will they be identified using a username from a username and password combo, which would be our standard SASL, or should they be only identified via the fields within the client set that connects? We want to use MTLS plus SASL here to be really secure, so generate username and password is selected. With that, all the controls are added. We can save that option and we can publish it to our internal gateway group. Now we've got two options available which serve the same data but different levels of security. I published that. I did publish, don't open it. So now that someone can come and subscribe to this. So they go to the catalog. I'm not going to change users here because I want to be more efficient in showing the new features, but typically someone else would come through with their application and want to subscribe to consume data. But here I'll just do it myself. So Kevin comes in and wants to use this option, requests access. That access may be approved after some discussion, and then comes back to the catalog to subscribe. At this point, whoever's subscribing has another option where they can check their cert that they've been given will function with MTLS, which you can see has succeeded here. So we'll subscribe. Another little quality of life feature that's gone in here is the download as properties. If I use this, when I download the file, I'll get a convenient properties file, which fits the format that most Kafka clients expect, for example, the Java clients or Node-RD Kafka clients. So it's a much easier way to get started quickly with a Kafka client. I'm not actually using one of those clients, so I'm going to use my own configuration. So I'll just copy those across. And I need to update my app to point at our new internal version of the data. And save that. And now if I restart my application, it won't work because I forgot about the MTLS. So I have to enable the client certificates and try again. And we give it just a moment, the application will continue working, now using MTLS and SASL to talk to that new option, which it has now done because it's consumed the first message. So that's great. At this point, the creator of the app could come back and remove their old subscription because they don't need it anymore. And go back, and now at this point, when we go back to our topic, we can remove that old option that we weren't happy with the security of by unpublishing it and deleting it. So now we've only got left an option which has got a high level of security on it because it requires approval Mutual TLS and SASL, and we've published it to our internal gateway, which is, let's say, behind a firewall. So the only people who can use it and consume the data are people who work within ModoGenes. So now ModoGenes are happy that they've secured their internal representation of the data. They're looking to move towards that public-facing version that we were talking about. So they're going to run a new gateway, which I'll grab quickly. Now, this new gateway, they're planning on running it perhaps behind a proxy that will be running in the DMZ. The proxy would give them a nice level of control over regions or IPs, where the gateway will give them a degree of control over the Kafka traffic that's coming in. So we'll run that, and we'll start creating a new option while that's starting up. So now I'm going to call this one store stock public. And we're going to add some different controls. So we don't want these approval and M2S controls now, because we're happy that anyone can come and access this data, provided we're in control of the data that goes back. So we're going to have a couple of redactions. This is a fairly simple example, so we're just going to get rid of, let's say, the internal IDs that people don't need to see. We could get rid of the contact information, maybe another ID. We could just start removing and redacting some fields. We'll stop there, save that, and we'll publish our new option to our public gateway group, which hasn't quite gotten ready yet. So we'll just do a quick refresh to speed things up. And now we can publish. So this option is now published to a different gateway that is now actually accessible publicly over the internet to people who can subscribe. Now, if we assume that over the period of the next however long, some people come in and begin subscribing and creating apps, then I can just quickly do that by creating some subscriptions using the admin API and starting those applications. If we give this a second, we'll see this new public version of the app will also begin working and consuming the data, and we should be able to see that the redactions that we put in place are in place. So the IDs have been removed, the contact information has been removed, so that's working as we intended to. And all these applications have been started and are trying to consume the data through this public gateway. So ModoGenes are pretty happy about this, but they're starting to wonder what might be happening to that gateway that they've left running publicly. So they start looking at their metrics. We'll actually just get rid of a few of these because we don't need to see them all for now. And immediately they start to see that they're getting a lot of authentication failure errors, which is a bit of a concern, because that means that someone's using lots and lots of bad credentials, because we're already at 100, it's only been under 30 seconds. So they want to have a quick look at that before they do anything else, and they have a look at their audit logs to see what's going on. And in the audit logs, they very quickly see they're getting a lot of people trying to connect with bad username. So that's a worry, why maybe we're letting lots of people retry connections with credentials that are invalid, and they're going to keep that in mind while they think about what else could be going wrong with their gateway. The next thing they look at is the amount of messages that have been consumed by the people who are subscribed. Now, I've only got 3 subscriptions, but the difference in message consumption is vast between the 3 things. So that's an interesting point. And in fact, if you look at the rate of consumption, one is running, or should be running, at roughly 5 times the rate that the other one is running, and another one is running so slowly that it's barely registering as consuming messages at all. So that's an interesting and concerning point as well. And finally, the number of connections that are being used to run these 3 subscriptions is very, very high. We'd expect a single consumer to run at about 4 connections per consumer, but we're at 43 to start with, and that's fluctuating down through 20 back up to 30. So there's something going wrong here. The expectation from this data is that somebody's probably using that one set of credentials to consume from multiple consumers. So they're massively overinflating the amount they're consuming, and they're massively increasing the amount of connections. And in fact, that is exactly what I've done. I've got a consumer running that's just massively repeatedly spamming with the bad credentials. I've got one that tries to connect, consume some data, disconnect and retry, one that's reusing the same credentials 5 times to produce that invalid data. So they're a bit worried about this, and they start to look at the feature that Matt talked about of securing their gateway. I'll quickly grab the settings for this and apply them before I talk about them, because otherwise we'll be sat waiting. So let me quickly apply that. All right, so what have they done here? What they've done is they've applied some rules to authentication, connections, and requests. The first says that any username that tries to connect, if it fails to authenticate, is only allowed to try another 5 times. And each time it retries, it's made to wait 5 seconds before it can try again. And if it fails all of those retries, that username will no longer ever be able to be used and will be held from attempting to connect for a very long time. Secondly, anytime that we close a connection on a client, we're going to hold that connection for 20 seconds plus or minus 3, and a single username is only allowed to have a maximum of 8 connections. And finally, any request that comes in from a client is not allowed to be larger than 1 meg. This doesn't apply so much to the consumers that we've got at the moment, but it might well apply if they look towards doing produce in the future through the gateway. Their thinking is that this will stop the repeated bad actors trying to connect with bad credentials, and this will stop those clients that are trying to reuse credentials lots and lots of times. And we can actually have a look at the impact this has had on our clients. So our properly behaving client has successfully reconnected and is now consuming properly. Our invalid credentials are still trying, but the time it takes between each retry has gone up massively. Our many connections has also been slowed down a bit by the fact that we're holding onto those connections, but it's not actually technically doing anything wrong as far as we can tell, so we can't really affect its behavior too much. On the other hand, the one that's reusing the credentials for lots and lots of consumers is very upset. Yes, it manages to consume a few messages, but a lot of the time it's just getting errors because it can't use as many connections as it's trying to use. And we can actually see this in our metrics as well. So the amount of failed authenticates has petered off massively. It's no longer climbing this excessive rate. The rate of consumption has been brought back down in line between the two consumers much better. And the connected clients, whilst still fluctuating, is lower than it was before we applied the rules. Sorry, 1 second. So with that, Redaction are pretty happy now that they've got much more control over the people who are using this public gateway. And again, they're thinking about what are we going to do next? How are we going to take this use of event endpoint management to the next level? And they're actually thinking about that produce use case. In fact, they're thinking, how can we enable a third-party seller, a third-party store to produce to our stream so that our users, so that our clients can consume that stream of information about the jeans wherever they're being sold from, not necessarily from our own stores. So they're going to go through that produce use case. They need a new event source for this, for our store stock topic, which is going to be store stock for produce. And within that, they're going to need to make a new option and edit the settings. So the first thing they want to do is mention the fact that this is a JSON stream and that there's a schema that you're supposed to use, which will upload, which is now done. And then they're going to start creating their options for this produce. So this option is going to be referred to as store stock third party produce, and it's going to have some controls. Again, they want approval because they want this to be approved third party stores. And in fact, they want schema enforcement because they don't want to make sure that the people who are producing these messages aren't going to put poisoned or misformatted events onto the stream, which are going to break the consumers. So they add both of those, save that. And again, they want to publish that to their public group, but we're still waiting for the validation again. Let me just quick refresh that to speed things up and publish it to our public gateway group. All right, so now there's a way of producing for approved clients. We'll go again through that approval flow quickly. Again, we'll just do it as the author rather than switching personas to speed things up. Press access. This access is approved, and they're then able to subscribe. I will take these credentials quickly and add them to my config for the demo. And then we can run a producer. So I run this producer, and what you might know is this is going absolutely wild. And Modo genes get made aware of this as well, because their clients, their consumers in their apps and the public ones are being completely spammed by the messages from this new third-party application. It's all coming through. It all looks like it's coming from this Cotswolds location, and Modo genes are starting to get worried. Again, they have a little look at their metrics, and already they're seeing, after having made this thing available, they're nearly at 2,000 messages. Right, the rate of production here is up near 100. And this is clearly not going to work. It's going to cost them money. It's not beneficial for the plan they had in the first place. So they need to stop this and make some changes. So what they do actually in this case is they decide to just delete that credential, which will stop the application that was using it from continuing to produce. And they go back to the drawing board. What can we do to give ourselves control over this option? So they unpublish it to see if they can make some changes. And that's where we come to our final new feature, quota enforcement, that Matt alluded to. So they have a look at the docs, they have a look at this explanation of how the produce quota will work. It will allow some messages through and then be throttled so that it keeps it under the rate, which is to mirror the Kafka behavior. And they're okay with this, they understand how it works, so they set up their quotas. In this case, they know that the messages are very small and that the rate shouldn't need to exceed one message a second, so they put the minimal rates in, and they add that as well as an additional control to that option, and they publish it back up, ready to try this again. So after having their application stopped, which we can see, the third-party store comes back and wants to try again, and they request access again. Now, maybe this time there's a bit more back and forth because they want to make sure that they fix their app before they will approve them access. They promise they have, so they approve it again, and they go through and subscribe once again. You can take those credentials. And they restart their app, funnily enough, having not fixed it at all. So it again tries to spam. But this time, what you'll notice is that after a little bit, it gets stuck. And that's because we're holding off those requests to bring it under the quota. And as we hold it, the amount of messages that's coming in, they're going to increase, which is referred to as back pressure. So then even more messages will come through, but then the delay will be even longer, which is what leads to that spiking in behavior. And because of this delay, you're actually able to see messages coming in from clients that are not behaving badly. And actually what you'll see eventually on this client, maybe we'll give it a bit longer by looking at the metrics, is that it will start throwing messages away because it can't keep up. So there's a spike that's come down again. The client is still trying to produce, and you need to wait a little bit longer before it starts throwing messages away. One. There you go. This is because of the back pressure. The messages are sitting in that producer for too long, and the producer says, these messages are getting too old. I'm going to throw them away now. They're never going to get sent. And I'll start trying with new messages that are coming in. So this is just going to start happening. The back pressure is too big. Maybe we're also hitting the request size limit that we put on the gateway. The messages just aren't able to get in. And at this point, maybe they finally twig that their application isn't very helpful. It's causing problems for them now because the messages aren't getting through, and they decide to stop it and fix their app and run a better version, which is producing approximately one message every second, which again will show up in the rate eventually, although the scale of this graph make it impossible because of the spiky nature that we had from the quota control. So yeah, that is actually the quick run through of all the features that we are referring to in the new changes to Event Endpoint Management. I hope everything was clear, and if not, please feel free to ask any questions about that and we can answer them the best we can. So thank you.
Okay, guys, why don't we, since we have a few minutes here, go back over the questions that have already been asked in chat, and maybe you can elaborate a little bit?
Yeah, of course. Just stop sharing the slides here and bring the questions back up. So thank you very much, everyone, for your questions so far. So a couple of questions I'll just kick off with here, one from Melis and one from Luke. Which kind of vendors of technology perhaps which use the Kafka protocol will Beam work with, or what Kafka vendors does Beam work with? Well, because we work at the Kafka protocol level, we actually work with any capability that respects and follows the Kafka protocol. So that could be, for example, Red Panda. That would, of course, be things like Apache Kafka and vendors like Confluent. So we have a lot of overlap and compatibility in that space. Yeah, I just see a question also just coming in from Luke. Do I need to change my clients to work with Event Endpoint Management? And again, because we're working at the Kafka protocol level, no, you don't. All of the hard work and complexity is dealt with by the gateway at the protocol level with the bits and bytes. And what that results in is effectively a Kafka looking endpoint. The gateway actually looks like a Kafka cluster and broker to your client. So the clients will be completely unaffected by that, and as a result you'll be able to like I say, plug and play a Kafka client, just changing out your standard bootstrap servers and of course your usernames, passwords, so on and so forth.
Okay, any of the other previous questions that we should expand on, or we doing okay?
No, so there's no actually from Melis about the form factors available for the Event Gateway. So at the moment, it is available as a container. That means it can be run on bare metal Docker if you prefer. But we also, of course, have an operator which will allow that to be deployed and managed by the operator on CNCF certified Kubernetes environments, as well as OpenShift. We are very keen to understand any particular use cases, or in this case, form factors. It would be useful to have the gateway available in to aid deployment. We recommend and suggest that you try and keep your event gateway, for example, in the same data center or geography as your Kafka cluster. And of course, containerization is not always available in all locations. So if there's any particular requests, be very keen to hear those.
Okay. All right, folks. Well, we're running a little ahead of schedule. Thanks, guys, for the demo. It's always great when you're brave enough to do a live demo, and so good job there. Our next session is going to be our guest speaker, gentleman that was part of creating Siri. So that should be an interesting little vignette that's going to start at 5 minutes after the hour. And then after that, we will have, let me get there, an introduction to Flink. All right, so that will be coming up at 20 minutes after the hour. All right. So let's go ahead and close this session down if we don't have anything else to cover, and we'll join you at 5 minutes after the hour. Okay? Thanks, gentlemen. Have a good day.
Thank you very much.
Have
a good day.